My name is not Alan Mason. If you're here for his talk, I'm not him. I'm also not Carmen Mason, but I'm giving a talk that she was supposed to give about MySQL HA using Orchestrator, ProxySQL, and Consul. People that were here for Colin's talk just before heard a lot about replication, heard about Orchestrator, ProxySQL. I will go into some detail how we implemented this. I'm not going to talk about anything VitalSource where Carmen works, because I'm not authorized to do that. I will make it more generic. So, who am I? I'm Matthias Crauwels, and there's only half of my face on that slide, so weird. I have a bachelor's degree in computer science. I've been a Linux user and admin for over 25 years. And I started my career as a PHP developer on the typical LAMP stack in the early 2000s. And that's how MySQL and I got acquainted, because there was no one else running MySQL at our company. So I started learning what it was and how to manage it. So that's how I came to be a MySQL DBA. Currently, I work for PlanetScale as an enterprise customer engineer. And I have a talk about PlanetScale in the afternoon at 3 p.m. this room. But now we're going to talk a little bit about just MySQL HA, just something about PlanetScale. We do a MySQL compatible serverless database. We are built on top of Vitess, which is an open source technology. It's a CNCF graduated project. And it's basically what scaled YouTube in the 2010 and beyond. Vitess serves a lot of QPS in production these days. So, but today we're not going to talk about Vitess, or not at least this talk. We're going to talk about MySQL HA. And there's three main components that I will speak about. It's Orchestrator, ProxySQL, and Consul. So let's jump in. So in this, why is half of the slides missing? Let's see if we can get that fixed. Oh, there it is. Weird. So we'll be talking about the regular asynchronous replication topology. I do apologize, I haven't been able to update the names. I still use master-slave here. These days we use primary replica. I will be talking primary replica, but yeah, I didn't have the source images anymore to change the names here. So what's high availability for MySQL from an application perspective? You need just one primary to and at least one primary to read from, replica to read from. That's very simple. And there's the image then. So this also makes, and I will have to do this every time, I guess. This also makes the single point of failure in the topology. So what happens if that primary fails? And eventually it will. Even you run physical hardware, you run VMs, you run Kubernetes, the primary will eventually someday fail. And that means that nothing can write to your database anymore. And that's likely to be a problem for your application, especially if you have an application that's supposed to be online all the time. When Facebook goes down, people call 911 here in the US, so it's kind of a big deal. And so what we will do is we will introduce a topology management tool to handle these kind of failures. Another important thing for high availability is your application needs to know where these servers are. Your application needs to know where to write to and needs to know where to read from. And that's something you could call service discovery. And what we will do in this presentation is we will use a proxy to make service discovery seamless for the application. So you keep just connecting to your proxy server, and the proxy will know where the database is. So the first component of this session is Orchestrator, and there was a nice logo as well there. And as Colin pointed out in the previous talk, Orchestrator currently is not really maintained, but there's been a lot of conversation to get it maintained again, because it's a really robust tool that's very well built. It doesn't need a lot of maintenance. Most of the features are there, and it's very customizable. So it is something that I still recommend to use. And what Orchestrator will do is 4 major features that you can use, and we'll go over these one by one. So first of all, Orchestrator can discover your entire topology. So if you point it to one of the servers, it will automatically start finding all the other ones. So the only caveat is it needs to be able to connect to the database. So if the user and password are wrong, it can't connect, so it can't continue the crawling. But it will say, like, there's something there, but I can't connect. And then you can fix that server or whatever. So if you just make sure that your user management is good enough, then you can deal with that. And so this is like the image of the discovery. So you basically give it a host name and a port and press discover, and it works. There's an API as well. There's a client tool as well. So you can integrate that with all your automation tooling to be able to do that. And then once it discovered everything, it will also visualize in the web UI the entire topology. And that was one of the first features that Orchestrator had. That was its original purpose, to visualize the topology. And that's very useful, I think, to see immediately in one overview how your cluster is doing. So this is probably a screenshot from a GitHub MySQL cluster, because Orchestrator was developed first at Booking, later at GitHub. And so this is what I assume to be an anonymized topology of GitHub. You can immediately see there's different colors in this diagram. Each color represents its own data center. So you can immediately see which data center is currently the primary. It shows you things like what version is running, what replication method, like this is all these servers are running a row-based replication with a full row image. It shows you which server is writable. This little pencil icon here designates that. It also shows these heart icons. They are the preferred servers for failover. If the primary would fail, then Orchestrator would prefer these servers with that heart icon to be the next ones. There are other designations like the GTID enabled, all of those things. Replication lag is shown here. If replication is broken, this box will be colored red, so you'll immediately notice when there's a problem in one eyesight. So that's a very powerful use case of Orchestrator. But there's more. So like Orchestrator knows the topology, so it can also refactor the topology. Things like repointing a replica to a new primary, promote a new primary, start or stop a replica, all of those things Orchestrator can do. You can do that using a command line tool, an API, or just drag and drop in the UI. So all out of the box. And then recovery is all of these features. They're very nice, but if you're a DBA and your server goes down at 3 a.m. in the morning, you get a page to fix it at that point in time, you're not going to be happy. So Orchestrator can automatically recover a topology from failure. And how that works, it first needs to detect a failure. And that's the main reason why Colin was talking about RDS earlier, and failures scenarios are now less than 35 seconds. I think that's still a lot. If your service goes down in peak time for 35 seconds and everything is waiting for it, it will be like a thundering hurt, and the next one is likely to go down again. So what typically happens in traditional monitoring is it will probe the primary. And what happens when the primary doesn't respond? Is there the primary down? Is the monitoring having a network issue? Is there anything else? So typically it will retry. But how many times will it retry? And how fast will it retry? It all depends. But as I've told, Orchestrator crawls a topology, so it connects to all of the servers. So it can see the topology from different points of view. So it sees the primary is down. So what it will do, and let's go back to this little image here. It sees the primary is down, so what it will do is it will call all the replicas from that primary. What is your view of the world? Do you still see the primary? If they all agree like, hey, we see the primary, there's no issue, then Orchestrator will say, hey, I have a network issue. I can't connect to the primary, but everyone else thinks it's fine, so why should I do anything? But if these all start to say, oh, I can't connect to my primary, I can't replicate anymore, then it's very likely that the primary is actually gone. And then it will, at the first detection, be able to recover that primary. So it declares it dead, and it will do something. And this is what Orchestrator calls the holistic approach to replication management. And so our example from before, okay, our primary fails. So Orchestrator is connected to all of them, and it sees, okay, this primary has failed, and they all agree, like, I can't replicate anymore. So Orchestrator will take one of these replicas, pull it up to become the new primary, and relocate all these replicas below that new primary. And the old one will be taken out of the cluster because it failed, and someone needs to look at it. So this is why you probably want to have more than one replica, because if your primary fails, the new one will get promoted, but you do not have any replicas left. In some cases, this can be like a failover scenario that you've initiated as a DBA, and then you can make sure that Orchestrator reattaches this server as a replica to your topology. That's perfectly possible. So, but by default, it won't. And so now you can see Orchestrator is now your single point of failure in a topology, and that's not good. So what you want to do, you want multiple orchestrators. So if one fails, the other two are fine. And you see the next single point of failure, we're just going deeper down the rabbit hole. So Orchestrator uses a shared MySQL backend, where it stores the information about all the servers it knows, and each node of Orchestrator then says like, hey, I will check this node, and I will check that one, and I will check that one. And if the backend fails, then it can't do that anymore, so it will be effectively down. So what you would then do is you would make your backend solution highly available, but because Orchestrator needs to be able to write to the database to do something, it cannot manage its own backend database. So you would need either something like circular master-master replication, or some kind of cluster like InnoDB cluster or Galera cluster. But then you have to manage that as well. So since Orchestrator 3.x, there's something called Orchestrator on Raft. And now every backend database for Orchestrator becomes standalone. No more application required. And it even allows you to drop MySQL as a dependency on that one. So you can just use SQLite, single file database. If you don't have thousands of servers, that will probably be fine. And then Orchestrator itself started implementing Raft for leader election and the distribution of data. And so in this case, you would probably want to have minimum 3 nodes of Orchestrator to have HA. So you have a quorum in Raft of 50% plus 1. So you can lose a node without losing your Orchestrator cluster. And then this becomes the difference. So in the synchronous database replication backend, you see that replication happens between the database nodes, and the Orchestrator nodes don't talk to each other. Whereas in the Raft version, the replication moves up between the database, the application nodes of Orchestrator, and the database becomes standalone. And you can then use like SQLite to co-host the database on the Orchestrator server. And important to notice is also, here you see only this one is the leader. That's the one making the changes. The other ones are still polling all the servers. And that's also an important difference. If you have thousands of servers, you probably want to stick with this one, because otherwise all of these servers will be polling your entire MySQL infrastructure, where in this case only one of them tells the database like, hey, I polled this server and I polled that server, and they will just cooperate, and the more nodes you add to Orchestrator, the more throughput you get on polling all your servers. Whereas here, if you add nodes, there will just be more connections to your database, and they will all be polling for the same information. So that's an important thing to note. That's why this synchronous replication backend has not been decommissioned yet for Orchestrator, because if you have a large infrastructure, you're going to want this, but if you have like a normal topology of, let's say, less than 100 servers, this will be fine. So, anyone questions about Orchestrator so far? Okay, so let's move to ProxySQL. So ProxySQL, there's the logo, is a layer 7 proxy, as Colin mentioned. It sits between your database and your application, and it's aware of the MySQL protocol. So it takes the connections from the application and it knows where to route them. It knows the topology, it knows the complexity of the topology, it can read the MySQL queries that you're sending it, so it can make changes, it can split reads from writes, and basically it protects the complexity of your database topology. It shields that off for your application. So your application just sees a proxy, and what's below that, it doesn't have to be aware. Some terminology. ProxySQL uses something called a host group, and that's basically a collection of MySQL servers, and that's where they send traffic to. Important to know is, if you send queries to a host group, it gets sent to only one server in the group. So if you have multiple servers in a group, only one will get that connection. So if you send a write, you will have to make sure that there's only one server in your write group, because if you send it to a group where there's multiple servers, one write will end up there, the other write will end up there, so you'll have a split brain. So that's important to know. Query rules is like the core functionality of ProxySQL. It's used to do the routing, so by default, ProxySQL doesn't know where to send anything, so you have to make a rule. This is where you send traffic. It can do mirroring, so there is a feature to mirror queries to a different host group, but it's to a different host group, so that's important to know, which is very useful for upgrade testing and all those things. It can rewrite queries, so it can, if someone writes a query that's not performant and you detect that, you can rewrite that. Or also, there's been a talk a few years ago about data masking with ProxySQL, so you can basically make sure if you select the credit card number that ProxySQL will only send back the last 4 digits. That's something ProxySQL could do. And then at the end, there's also some kind of query firewall. You can block certain queries from happening, like you could make a query rule to say, like, I don't want any deletes without a where clause, which might be useful. If a developer does delete star from deletes from table, where, okay. And then MySQL users and servers, these are needed for MySQL to know where to send traffic to. And because the proxy sits in the middle, you need to authenticate to the proxy, and then it continues to the server. So, basic design, you have your proxy in the middle, you have your applications connecting to the proxy connecting to the host groups. And I can see you thinking, Matthias, this is a single point of failure. But this proxy block here can actually be a lot of proxy servers. You can basically scale that up to as many as you need. And you can basically load balance between all of them. The only thing you need to do is you need to make sure that the proxy configuration is in sync. There is a clustering, we'll come to that. But besides that, there's no limitation on how many proxies you can run. Or some people run it like this, like they run ProxySQL on their app servers. And then from there, the app connects locally, and then ProxySQL connects to the right database. Or anything in between. So ProxySQL can also cascade itself. So you can have this, connect to a proxy in the middle, connect to the database. Perfectly fine. ProxySQL clustering. You can share configuration values with its peers. And all instances in the ProxySQL cluster currently are treated equally. So the first one to make a change pushes it to the other nodes, and the other nodes reconfigure themselves. There's no leader or master or whatever. It's a feature that's on the roadmap, but it's been on the roadmap for a while, so I don't think they'll implement it anytime soon. And so this clustering really helps to avoid ProxySQL to be a single point of failure, because you can just have many proxies. And you don't have to reconfigure every proxy individually. So you can configure one, and the rest will auto-apply the configuration through the clustering. And so a while ago, I wrote a blog post about how you can use this feature to auto-scale your ProxySQL in the cloud. Like you have an auto-scaling group or a managed instance group, and your proxy servers can just scale as your traffic ramps up. And so what it will look like then is this. So you have a number of proxies on top where your applications connect to. You have your write traffic being directed to your primary from all the proxies, and all the read traffic goes through all the replicas. And then from the backend, you have Orchestrator managing all of the servers. So what's next? So we want to eliminate all single points of failure in this topology. And we've talked about Orchestrator, and we've talked about ProxySQL. But how will ProxySQL know when the master gets changed? And how do we eliminate network failures between both of these applications? So that's where ProxySQL has a feature called read-only flag monitoring. And then ProxySQL will monitor MySQL's read-only flag or super read-only flag in later versions. And it will basically check which server is writable. I will send writes there. Which server is readable, I will send reads there. You need to have the monitoring user configured correctly, because otherwise it can't detect whether it's read-only or not. And you can have Orchestrator set apply MySQL promotion after master failover. The variable names have been, but this flag will, if Orchestrator promotes a new server, it will automatically toggle the read-only flag on the old one and the new one, and that works well. But before 3.0.12, this was default false. Since 3.0.12, it's default true, but it's always been recommended to set this to true. And this also kind of relies on MySQL being read-only by default. So if a MySQL server comes up, you should have it read-only by default, which is a best practice. So if anything comes up in a topology, you can't write to it. That's just a fail-safe. And there are some caveats here. So what happens if your network partitions? So Orchestrator sees the master being unavailable, the replicas agree, and Orchestrator makes a new promotes a new master. The old primary is still writable because Orchestrator cannot reach it to toggle the flag. So ProxySQL will notice that old master primary is gone, and it will make it something called shunt, so it's not sending traffic to that old master anymore. And it will move the new primary to the writer group. Works fine. But then the network engineer fixes the network, and the old server becomes back available. And ProxySQL will see, hey, this server is back available. And nothing touched it so far. So it's still writable, because it was writable before, because it was your primary before. And so ProxySQL will see it coming back and say, hey, this is a writable server, so I will put it in my writer host group. And now you have two servers in your writer host group, and you have a split brain, which is not what you want. Workarounds, you can shoot the other node in the head. So if you have a cloud system, you could call your cloud API like this machine needs to go away. or needs to reboot, or whatever. Or you can have a scheduler script in ProxySQL that deletes any shunt writers from the configuration. And that's also works, but that's also kind of dangerous, because if you have cascading failures, all your servers will get removed from the group, and you'll end up with nothing. So Orchestrator has this concept of hooks, and they are called in various stages of the recovery process. So when it makes the discovery of a problem, Orchestrator will call a hook, say, hey, I found an issue. And then, depending on its configuration, it says like, hey, I'm going to do something. And then it says, hey, I done something. And it failed, or it succeeded. Or by default, Orchestrator writes to a log file in temp. It's very naive, because if you restart your server, you lose that log file. So be sure to change that. And if you do not want to script using these hooks, use them to alert. Like, send a Slack message to yourself, like, hey, I detected something. Hey, I made a change. So you are aware that something happened. Why? Instead of relying on ProxySQL monitoring, the read-only flag, we can now push changes from Orchestrator to ProxySQL. So if you have a planned or unplanned failover, you could send pre-failover hook, like remove the failed host from the writer group. And post-failover, the recovery was successful. This is the new primary. So use this one as a new primary for now. If you want to automate this, I can't stress enough, test, because there's edge cases, there's a lot of things. Before enabling it automated in production, be sure that you are certain that it works correctly. And this is great, but what happens if Orchestrator cannot communicate to ProxySQL? Like, your network is still the issue. A hook is only fired one time, and if it failed, then what can you do? You can stop the failover, sure, that works, but then you don't have a primary anymore. You need to have ProxySQL admin credentials available on Orchestrator, because it needs to change ProxySQL configuration. Some people might think that's a problem, some people don't. So this is where Consul and Consul template will come in. So we want to decouple communication between Orchestrator and ProxySQL, and we basically use Consul as a key value store in between both. Why Consul? Orchestrator has native support for it. Orchestrator can automatically update any Consul server that it knows, and Consul by itself is a distributed system. So it's highly available by nature. It's also Raft-based. And so you can basically put your configuration to make it highly available. You put a Consul agent on your Orchestrator node, and you connect to the local hosts of the Consul agent, and that will know where the primaries are. And so what will it store in Consul? It will do this. So it has a key value cluster master prefix, and that's like MySQL / primary. And so what it will store in Consul is, for this cluster, my cluster, this is my primary host name. And also, like, for scripting purposes, there's separations like the host name, the port name, the IPv4, the IPv6, depending on how you want your automation to work. And so, how can we avoid single points of failures? So the recommended setup for Orchestrator is to run 3 nodes. And so for Consul, it's the same. So you can basically co-host Consul server and Orchestrator server on the same machines. And Consul server also comes with an agent, and the agent knows the whereabouts of all the servers. And the Raft protocol makes sure that it always writes to the leader node. And so we let Orchestrator send updates to its local Consul agent. Consul agent updates the Consul leader nodes. distributes the data across all the console nodes. And now you have HA for both Orchestrator and Consul. We avoid network partitioning because we're talking to the local instance. If the local console goes down, then the local Orchestrator is likely also to be down or unavailable, and so it will never be the leader node. If it's separated from the rest of the group, it will never be leader. And optionally, Orchestrator has extended the RAF protocol a little bit to yield for a specific leader. And so what you could do is to just yield Orchestrator to have the leader node on the leader node of Consul, so they can communicate locally. It's not a requirement, but it makes things faster. What about replicas? Orchestrator doesn't really care all that much about replicas. If a replica goes down, nothing will get triggered. It's only when a primary or an intermediate primary goes down that it will relocate replicas, so it will try to keep them replicating. But if the replica goes down, it won't do anything. But there's an API. So if you can script a little bit, you could write a bash script to just crawl the API in the JSON response and just update whatever is in the API to be stored in Consul as well, because we all are already using Consul. We were using MySQL/primary for the master prefix, so we can use something like MySQL/replicas. And it will update Consul wherever needed. And so what you can then see is that you have 3 Orchestrator nodes. In this case, I co-located my Consul server with my Orchestrator nodes. And I have 2 ProxySQL nodes, and these are clients. And they can read the same data from the Consul server. And so now we can just query the data locally on ProxySQL. And what we then do is we implement Consul template. Consul template is something delivered by HashiCorp as well. It's a templating engine. So based on whatever stored in Consul, it will generate a file for you. And that file can be a SQL file to reconfigure ProxySQL. So in this case, it will check if the key of the primary exists, and it will then update the primary host group, and then it will loop through all the replicas, and it will add them to the secondary host group, and then it will commit the data into ProxySQL. And ProxySQL can be automatically reconfigured from whatever Orchestrator changes. And this is what it then looks like. So you have your MySQL topology in the middle. You have your Orchestrator on the bottom using Consul in the local SQLite storage. You have ProxySQL on top, and you're running Consul template here. So it's watching the data in Consul and updating itself to know where the primaries are. Any questions? Then I would like to thank you.